part C.2, insertion operation. In this part, let us discuss the details of the insertion operation. First, when we start, so let us look at the analysis we did in the previous video. In the previous video, we do this kind of operation. We insert a new element into the current already sorted array. All right. So then we make that step some abstract insertion operation. Here, let us look at the main properties of this insertion operation. First property, we need to find the right position to be inserted for the new element. Right position, somewhere in some position in the current sorted array. We need to find that location. After that, we need to move elements to make the new element inserted in the right place and get a whole array sorted. So that's all we need to do. All right. So based on these two properties, we can implement that insertion operation easily. So let us look at the implementation. Implement insertion operation. How to find the correct position for the new element. There are two different ways. So here, I like to look at those two different ways. All right. The general case like this. Let us assume this array already sorted. Then we need to add a new element somewhere in this array. All right. To find the location, so to find a location for the new element, basically there are two different ways. So it's a search operation. So if you look at that, how to determine the right position for the new element. So you can see it is a search operation. Search in the current array to find the right location for the new element. Not search. So here it is not a standard search, but it is a kind of search. Not exact the standard search. So it is it is a modified search. Not exact the search we are talking about. We discussed it before. But if we modify our standard search a little bit, we have this situation. So that's the reason I want to mention the search. All right. Because later, there are two different ways corresponding to two search methods. Sequential search and a binary search. When we do search, typically we have these two ways. Linear search or sequential search, another one, binary search. These two methods. All right. Next, after we get the right location, then we need to move the elements to make the new array sorted. The new element needs to have a location, position in the array. So you need to move some of the elements to make that right location vacant for the new element. So that's the reason we need to do step 2. All right. At this point, I like to ask you one question. Yeah. Because we know for this step, if we use the asymptotic notation to represent the number of comparisons we need to make, we use big theta of k. Big theta of k. Yeah, you know the meaning, big theta, right? You can imagine just some constant multiple times k. Yeah. So that's what we mean. Yeah. The number of comparisons. Yeah. All right. But here I may ask you, what is the average case efficiency? Yeah. This is asymptotic, but this question I like to ask you more precise expression. Now we need to get a more precise expression. Okay, yeah. But if you just use your basic intuition, you may give me this k over 2. Yeah. So this one, if you treat it as an approximate answer, yeah, so that is okay. Approximation, but it is pretty close. Yeah. All right, but the next step, I may like to ask you exact answer. Do you know how to find exact answer? Yeah. When we insert new element into its right location, you need to do certain number of comparisons. Here I ask you to calculate the average case efficiency, and I ask you to give me exact expression formula. Can you do it? All right, yeah. Here I give that question to you. Yeah. Because later when I do exercise questions, I will talk about that. Yeah. Later, I will give you some exercise questions, yeah, practice questions. Yeah. Then I will discuss how to find that average case efficiency. Yeah. You can try yourself first. Later, you can look at my solution. Yeah. All right, so next, this time, let us do that insertion operation in details. Yeah. Shift elements for insertion, because we need to move elements to leave some space for the new element. So we do that shift operation. Yeah. All right. Shift elements to the right. Yeah. So that's what we do here. Yeah. All right. At starting point, we want to insert this A sub k somewhere in the existing solid array. But when we do it, we do this way. Yeah. Implementation detail. Yeah. First, let's assume the right location is here. Let us assume the right location is here. Yeah. But we need to move all these elements one position to the right to leave this location for the new element. How do we do it? Yeah, so we do this way. Yeah. All right. First, we move A sub k to a temporary location. So this is a temporary location. Yeah. We copy it to some temporary location because we want to make this location empty for a new element. All right. Then, all right. So we compare AK with AK minus 1. If AK minus 1 is greater than AK, we move it to its right position. Yeah. Shift one position to its right. Yeah. We need to do one comparison. Yeah. If a sub k minus 1 less than or equal to a sub k, we do not do anything. Okay? We stop. We stop because that means a sub k already in its right position. So we do not need to, even copy to the temporary location, right? Yeah. All right, but if it is greater than a sub k, then we do that right shift. Yeah. Similarly, then we compare with the next element. If it is greater than the current element, we shift one position to its right, and so on. All right? Until we shift the last element, a sub I plus 1, to its right position. After that, there is a vacant location for our current element. So we copy that a sub k to this place. Then we complete the standard insertion operation. Yeah. So that's all we need to do for this standard insertion operation. Okay, that's it. Yeah. So we complete it. Yeah. All right. So here you can see, after we complete this operation, we pretty much complete the whole insertion sort. Yeah. Because this is a general insertion operation. After that, we can do the same thing again and again until we get all the elements inserted in the sorted array. So the whole array is sorted. So we're done. Yeah. So in our next video, C.3, we will look at the whole procedure. Yeah. Because when we look at whole procedure, we will do efficiency analysis. Yeah. We want to see how many comparisons do we need for the best case, for the worst case, and for the average case. Yeah. All right, so let's stop right here for C.2.